Welcome back. Today we're going to take a look at EPE worksheet, or more specifically energy, power and efficiency worksheet. Alright, that's chapter 2 for IGCSE and chapter 1 for IGCSE and chapter 2 for those of you taking SPM. Alright, this worksheet is generally quite easy. I'll say this part of your syllabus is actually quite easy, but in order to do this worksheet, you need to know at least 5 equations. Alright, what are those 5 equations? Those 5 equations is, first of all, work equals to force times distance, which will give you a SI unit in joules. GPE, or gravitational potential energy, where mass times gravity times height, where again if you calculate everything it will be in joules as well. Alright, then we have kinetic energy, half mv squared. Alright, half times mass times velocity squared. Again, SI unit is in joules. Alright, then we have another energy called the spring energy. Alright, that is another potential energy, spring potential energy. The formula is in half kx squared. Alright, if you follow my class, you know that potential energy for spring and gravitational, they are both potential energies. SI unit is in joules. Power equals to energy, or work over time. Right, remember, work, energy, they're all the same thing. They're all joules. So work over time, SI units here is in watts. Once again, I'm obligated to remind you, if you're not familiar with any of these formulas, or you think you're not too sure, go back and read your notes, or go through your revision book. Do not attempt the worksheet before being familiar with all 5 of these equations. Once you're familiar with the equations, to do the questions in this worksheet, it's pretty simple. All you need to do is read the question. Right, for instance, let's take a look at question 1. Question 1 says, an object of 2 kg mass is pulled by a force of 25 newtons. If the object is moved over a distance of 3 meters, what is the work done? So the question here states pretty simply, it says work done. So let's go back to our formula sheet. It's what is the work equation? The work equation is this one here. Work equals to the force times the distance. All right, so let's do the first. Draw a box. So the force being pulled is 25 newtons and the distance is 3 meters. All right, we can ignore the mass because the equations says it's work times force times distance. It never says anything about the mass here. All right, of course, it's if you go to a higher level, all right, the mass does affect other things, especially like friction, not part of the syllabus, especially IGCSE students. So force is 25 and distance is 3 meters. So what's the SI unit? It's in joules. So 75 joules. Pretty simple. Let's take a look at another question. Question 4. The figure shows a boy of mass 40 kilograms pushing a book downwards with a force of 200 newtons. Calculate the work done by the boy. So once again, work equals to force times distance. Right, the force is 200 newtons. But what is the distance? Right, you're pushing on the floor. The floor is obviously not going to move. So the distance is going to be 0 meters. This is an interesting thing about work. It doesn't matter how big your force is. You can apply 1 million newtons if you want, or 0.01 newtons. If nothing moves, your work done is 0 joules. It's like it's telling you that you're not doing any work. It doesn't matter how hard you push. If nothing works, you're not creating any useful work. Let's take a look at another question. Question 6. All right. The question says, calculate the kinetic energy of 20 grams of tennis ball traveling at 40 meters per second. The question says kinetic energy. So the formula for kinetic energy, you should have memorized it in your heart by now. Or as I like to say, understand the equation. Half mv squared. So it's half times, one thing, important thing to note, always bring every unit to SI unit. So in this case, 20 grams is the mass, but grams is not in SI. So what you do, you're going to take 20 divided by 1000, which will give you 0.02 kilograms. 0.0. Always bring to SI unit. 40 meters per second, that's the velocity, but that's already in SI units, so it's 40 squared. if you plug into your calculator, you find that it's 16 joules. You will get around you will get 16 joules exactly. Let's take a look at one final question. So let's take a look at question number 9. Alright, so a boy throws a pebble vertically upwards at 15 meters per second. Let's draw this out. 15 meters per second. What is the height reached by the pebble? Right. So let's understand what's going to happen. When he throws a stone up, the stone is going to travel at an initial velocity of 15 meters per second. The stone is going to go faster or slower. It's obviously going to get slower and slower. The reason is the maximum speed is right when it leaves the hand. The reason why it gets slower is because there's going to be a gravitational pull downwards, 10 meters per second squared. Right. I like round numbers. Gravitational pull downwards. So it's the maximum height is when the velocity equals to 0 at the top here. Right, there's two methods of doing this, but I'm going to show you using the gravitational potential energy method. So at the maximum height, what do we say? We say that at maximum height, potential GPE, gravitational potential energy, is maximum. And kinetic energy is equivalent to 0. Why 0? Because there's no more velocity is 0 at the top. So kinetic energy, if you recall, is half mv squared. So velocity is 0, so kinetic energy is 0. So what happens is that all the kinetic energy has been converted to potential energy. So what we're going to do is that we're going to equate both equations together. The gravitational potential energy, all the kinetic energy has been changed to gravitational potential energy. So let's equate them together. So half mv squared equals to mg times h. The mass is the same, so both sides can be cancelled off. So half v squared equals to g times h. Half times 15 squared, okay, times 10 equals to h. If I were to rearrange h, what will I get? I will get half times 15 squared. You get 11.25 meters. Right, that's another method of doing this. I'll show you guys another time.